A view-dependent effect is an effect where the visual appearance changes based on the user's view. Many of these effects occur naturally in the physical world, like lens flares and bloom, and are commonly used to enhance traditional film and video game experiences. However, in 360-degree video, there is no runtime component in which to encode these effects directly, forcing the filmmaker to choose a single appearance for each scene element regardless of the user's view. This can lead to undesirable artifacts such as unwanted gradients on the equirectangular frame. We present a method that enables view-dependent effects for 360-degree video. Our approach uses the current viewing vector of the headset to interpolate over a sparse set of spatial keyframes using radial basis functions. Here we show a side-by-side of the per pixel and view-dependent effect variants. This allows filmmakers to apply a uniform effect across the entire field of view of the headset for any location and direction in the video. View-dependent effects can be used for creative or realistic purposes, like enhancing the overall immersion of the 360-degree video by incorporating bloom-like effects, as well as helping with gaze guidance by utilizing dynamic color and exposure techniques, or to help reduce motion sickness through the application of dynamic vignettes. We develop both a video player and authoring system to enable VR professionals with the tools to both view and create view-dependent effects. Our authoring system is motivated by interviews with leading VR film production studios. The UI is attached directly to each hand, where the left hand contains the effect authoring interface. This allows the user to place spatial keyframes, change the active effect, preview the effects, and modify their parameters. The right hand contains the timeline interface. This provides controls to scrub the timeline, traverse markers, and to preview the unaltered video. The spatial keyframes can be visualized through small timeline markers. To help the user predict and visualize how effects propagate throughout their film, we developed two different effect visualizers. The first, the effect minimap, allows users to see how a particular effect propagates across space. Second, the effect tracks can visualize how an effect propagates temporally for a particular viewing direction. To evaluate the practicality of view-dependent effects, we conducted two studies. The first study investigated the application of view-dependent effects using our authoring interface with professional VR filmmakers. Here are 4 of the produced videos with the color styles of each filmmaker realized using view-dependent effects. The second study investigated the perceptual aspects of view-dependent effects with the general audience. Here, we flip back and forth between the same effect parameters rendered per pixel and view-dependent so viewers can compare them. Results show that experts find view-dependent effects useful for their narrative and creative purposes, and that these effects can evoke new experiential sensations for a general audience. See the paper for details.